In today's video, we're going to be solving linear scenarios algebraically. So we're going to be taking a look at two different scenarios and answer certain questions involving those scenarios and knowing what we know about systems of equations and how to create linear functions from a scenario. All right, so let's take a look at this one right here. We have Ariana opened up a savings account after her sweet 16 birthday party with plans of using the money to purchase her first car. For her birthday, she was given $200 in gifts, and after 10 months, she has $950. Create a slope-intercept function rule to represent her savings. Okay, so what I'm going to do in this scenario, I can't really tell what the rate is because you don't see a per or each or some sort of terminology that represents a rate. So when you don't see that, you create a table. We have X and we have Y. So the Y is going to be her savings, right? And the X is going to be probably the number of months in this case. All right. So on her birthday, she was given $200 in gifts. So automatically, she was given $200. That was her initial value to start off with. Let me write better zeros. There we go. So at 0 months, it was $200 because that's the initial amount. After 10 months, she has $950 in her savings. Okay. We find the slope by the difference in the y's over the difference in the x's. So the difference in the y's, 950 minus 200 is 750. 0 to 10 is 10. When I reduce those, basically you just cancel out the zeros and it's just 75 over 1, which is 75. So this means she saved $75 per month. And she started with 200. So her slope-intercept equation is y equals 75x plus 200. All right. Here's another scenario. Isabel had a sweet 16 party as well, and her savings is represented in the graph below. Create a slope-intercept function rule to represent her total savings. So I'm going to just take a look down here. And she looks like she starts off with $400 and then goes up to $600 every 4 months. Okay, so it looks like it goes up it goes up to 600 every 4 months. So this is 4, and it looks like it goes up 200 here. So the slope for this scenario is 200 divided by 4, which is 50. And we know the slope of this one. Do we know the y-intercept right there is 400? So this equation is y equals 50x plus 400. So we have both our function rules right here for Ariana and Isabel. All right. And again, there's other ways you could figure out this slope. I tried to do it easier with this one. Went up 200 divided by 4. All right. You could have done up 100 divided by 2 and still got 50. All right. So I just try to use the numbers in the chart to help me. Okay. So it's to determine algebraically, how long will it take for Ariana and Isabel to have the same amount of money? Same means equal. So I want to make an equation using their function rules. I want to see when Ariana and Isabel, have the same amount of money. So we have 75x plus 200. We want to see when that is the same as 50x plus 400. So basically, we're solving this system using, you got it, substitution. Okay, let's solve this equation. Let me get more room here. It's a little crooked. It's all right. So we minus 50x from both sides. And we're left with 25x plus 200 equals, these cancel, 400 minus 200 from both sides. And you get, those cancel. You get 25x is 200. Divide both sides by 25. And you get your final answer. 200 divided by 25 is 8. So 8 months. That's when they're going to have the same amount of money. Okay, so that's how it all ties into the systems unit. Let's take a look at another scenario. Harold bought a car for $2,000, which depreciates in value $1,000 per year. Create a function rule that represents the value of Harold's car. So this one is nice because it gives us the initial value. So that's my B, right? And it gives me my M because you see the word per year. That means there's a rate. So that's going to be my M. So my equation is going to be Y equals, now depreciate in value means it goes down $1,000 per year. So negative 1,000 x plus 20,000. Okay, so that is my equation for this one. Don't forget the negative. That's the most important. I should put a comma there if I'm going to put that. All right, so remember, depreciates means you have a negative there. Okay, Brianna bought a car that's values represented in the graph below. Create a function rule that represents her car value. All right, it looks like, okay, this is between 28K, was 28,000, and 32,000, which is 30,000. So that is my y-intercept. And it looks like to get to this point, it goes down to 24,000. So it goes down 6,000, right 4. So this goes down 6,000 to the right 4. So my M for this one is, let me figure it out, 6,000 divided by 4. Divided by 4 is negative 1,500. Okay. So I know the slope of this one and the intercept. So the equation is y equals negative 1,500 x plus 30,000. Do you have enough room? I hope so. Yep. So there is my function for Brianna. Here is my function for Harold. All right, let's answer our question. How many years will Brianna's car value be 5,000 more than Harold's car value? Now, we don't, like the last one, we don't want to know when they're the same. We want to know when Brianna is going to car value will be 5,000 more than Harold's. So I'm going to give myself a little bit more room. So I want to know when Brianna's car is going to be 5,000 more than Harold's car. So that's kind of like the pre-equation, I call it. Okay, Brianna's car, we want to figure out when that is $5,000 more than Harold's car. So Brianna's car is this function right here, right? So we're going to take this and plug it in, or not that whole thing, just the expression part. Right, we're going to plug that into Brianna's, right? So we have negative 1,500 x plus 30,000, excuse me. Okay, and we're going to plug this portion in to Harold's, right? Equals negative 1,000 x plus 20,000. And don't forget the 5,000 at the very end, the plus 5,000 at the very end. All right, let's make more room for our equation here. Big numbers. Okay, simplify this. We got to add these two like terms together, right? 20,000 plus 5,000 is 25,000. Bring everything else down. Okay. I want to bring this one over here, so I'm going to add 1,500 x to both sides. That'll cancel these out, and then I'll be left with a two-step equation. So negative 1,000 plus 1,500 is 500 x plus 25,000. Minus 25,000 from both sides. And you're left with 5,000 equals 500x. I know this off the top of my head, but if you need a calculator, you divide both sides by 500. 5,000 divided by 500 is 10. So 10 is the amount of years that Brianna's car is going to be worth 5,000 more than Harold's car. Okay, so that's your answer. Okay, so using all the skills we use to create slope-intercept form equations, and now just applying the substitution rule with our systems and solving the scenarios. All right, so that's it for today's video. Thank you for watching, and always remember, whether you're solving for X or Y, always give math a try.